All right, we are live. Welcome to BAM TV episode 3. What is a local area network? And in this episode, we are going to be covering quite a few things, so we're going to go pretty fast. Forgive any crazy background noise like screaming children or, oh, dad, so and so's hurting me because my kids are home from winter break, and that is very likely to happen. All right, so what is a local area network? This is a concept that a lot of folks tend to struggle to wrap their mind around, and it's a concept that is very important for you to understand if you are going to be working in building automation as a salesperson, an engineer, technician. Doesn't really matter what role you're going to be doing. It's important to understand what a local area network is. So a local area network essentially is a local network. But what does that mean? Because that can be deceiving. Well, back in the olden days, like back in the early 2000s, actually back in the 90s, you had a switch, and a switch is a piece of network gear. You've probably seen these in your house if you have a cable modem or a DSL modem. On the back of it, you have these 4 or 3 or 2 Ethernet ports where you plug in a cable. And those cables, those ports as they're called, allow you to connect devices. So a switch allows you to connect devices to a local network. And so maybe one device would be a laptop, maybe another device would be a desktop, and maybe another device would be a television. Now, I'm not even going to try to draw a television, we're just going to put a person on here. So a switch contains all of these devices, also known as hosts, and it contains these hosts on a local network. Now, what is a local network? Okay, so in the world of networking, you have what is called the OSI model. And I'm not going to bore you by going into too many details with this, but essentially the OSI model is a model that lays out how things communicate. Okay, so it lays out how you're going to go about communication. And what the OSI model defines, at least on the lower levels of it, layers as they're called, you have a physical layer, you have what's called the data link layer, and you have what is called the network layer. You have 4 more layers on top of this, so there's 4 more. There's 4 through 7, because these are 1, 2, and 3. And what these layers do is, as a message is sent, it goes through kind of these layers. And a message would be some form of communication between one device, maybe this computer right here wants to stream a movie to my TV. So it would go about sending a message through the switch. Okay, so physical is the actual physical connections here and the actual physical wire. So this is the signaling. This is how messages are sent. The physical is also the wire itself. The physical is all about the ones and zeros, because in the world of computer, everything is ones and zeros, or bits. And we discussed this, I believe, in episode 1, where we talked through direct digital controls, and we talked through how they started using digital signals, ones and zeros. Well, networks use ones and zeros. And this will be important, this kind of bit concept, when we come back to this. Okay, so that's the physical, and I'm doing a flyby right now. The data link is going to be all of the stuff on the local network, okay? Oops, don't want to drag that around. I don't even know how that... I am still learning this computer here. All right, so the data link is all of this stuff on the local area network, okay? And that is where you're going to have MAC addresses. That's where you're going to have Ethernet, things like that. Now, if you don't know what MAC addresses and Ethernet are, don't worry, because we will talk through that in a little bit. So I'm going to clear this out and make this a little bigger now. So a local area network, as we talked about, has a switch. And it's not always a switch. It could be a router switch combo, but it's basically something to do the switching. And you have hosts that are connected via links between their ports and the switch's ports. So you've got links. And then this switch, so this is a LAN. This is a contained LAN. Then this switch may, via a trunk link, go to a device called a router and then communicate to a local area network over here. Now, we're not going to touch on this because this is focused on LANs in this episode. But what's going on here is this switch may be its own local area network. And then over here, you have another local area network. This local area network 1 right here, local area network 2 right here. And by default, without some sort of device to facilitate communication between LANs, they can't communicate to each other, okay? So LANs are not going to be able to communicate to one another by default. That's how things work. Now let's pull back and we're going to talk through each one of these layers in greater detail because it's important for you to understand them. So the first thing is the physical layer, right? So the physical layer is going to control what is called signaling. So if you've ever gone and seen a digital signal essentially is ones and zeros. And that's important for us because for our computers, for our direct digital control devices, DDC, BAS field controller devices, in order for them to be able to process data, it has to get converted into ones and zeros. So what happens with signaling is that the physical standard defines, is 1 going to equal an on value or is 1 going to equal an off value? I'm not going to get into the different types of signaling. I learned this stuff when I went through my master's degree in IS, and I forgot it as quick as I possibly could because there's multiple different types. But the important thing is that you understand that the wires that these signals travel across are defined via this physical standard. It also defines wire types. So this is where you'll see things like Cat5 cable, Cat6 cable. And here's a little trivia question. Is Ethernet Cat6 cable? Because you often hear folks say we need an Ethernet cable. But the thing is, you can have Ethernet over fiber. You can have Ethernet over wireless. Ethernet is not a cable standard. The cable standard is Cat6, Cat5, and then the RJ45 heads, these little heads that take in 8 wires. You've probably seen them before. Those are another standard. But Cat6 is the type of cable, and Ethernet is the standard of communication. Which brings us to right here, our data link layer. Okay, and I'm trying to make this as not dry as possible. I realize that this is a fairly dry topic, but it's a very important topic that I see a lot of BAS folks don't understand, and then they spend time troubleshooting data link issues. Or thinking they're troubleshooting data link issues when they're really got IP issues and vice versa. And this is something that with IP controls is just really important to understand. So on the data link, you have your switch, and your switch is going to go and communicate to your devices via links. Now, here's the thing. On your devices, we're just going to blow one of these devices up right here. You will have a port, and this port will have a NIC, a network interface card. And this NIC will have a MAC address. And the MAC address is the physical address of the network information card. Now that's important to know because here at the data link layer, we're only communicating on a LAN. We cannot communicate LAN to LAN on the data link layer. So if you are trying to communicate to another subnet, which that's a whole nother topic we'll talk about in just a bit, but if you're trying to communicate to another network, that cannot happen at the data link layer. So this is important to understand because if you go and you are having an issue where you can go from one device to another device. So let's say this is host 1. And let's say over here is another LAN. So, and then this is host 2. And let's say that you can communicate from host 1 to host 2, which is on a different LAN, LAN 2, LAN 1, and all the settings in host 1 are the same as here in host 3, but host 3 cannot communicate to host 2, then you most likely have a data link issue. And it's important to understand that because what that means is that's going to change your approach to troubleshooting. You're going to go and use different troubleshooting tools. You're going to go and look at different settings in a switch if you actually are doing that. I know a lot of folks make a big hoo-ha about going and getting Cisco certified as a BAS tech, but to be quite honest, on any medium to large size building or enterprise, they're not going to let you work on their networks anyways, so it's just more important to understand the concept so that you can point the IT folks who are going to do the troubleshooting in the right direction. But so if these settings, as I said, the IP settings were the same in host 1 and 3, you most likely have a data link issue. Now let me clear this out again and we'll talk more about data links. All right, so when a device connects, and I'm just going to call this DL for short. When a device is plugged into a switch, what happens is a switch sends out a ARP message, right? And you have what's called an ARP table. And essentially, this switch is doing address resolution protocol, and it's essentially finding the MAC address for these hosts and then storing it into a table. So the MAC address would go and would store right here in this ARP table. And let me show you real quick what a MAC address looks like. Let me see if I could do that here. So you can see a physical MAC address right here for my Bluetooth network interface card. That is what a MAC address. It's hexadecimal, so 0 through 16, and once you get above 9, you start to go into the alphabet. All right, so the MAC address stores right here in this ARP table. So the MAC address is going to store in the ARP table, and then it's going to correlate to an IP address. Let me see if I could pull up an image of a ARP table real quick, and let me see if I can show you what that would look like. So here we go, view image. You can kind of see IP address, it's Ethernet, here's the hardware, and then there's the interface. So what happens is that this port knows that the MAC address is assigned to this port and assigned to this IP address. That'll become very important when we move into layer 3 a little bit later, because this is how the resolution of IP addresses is done. But the big thing here is that you've probably heard the term MAC address on BACnet MSTP before. And that's because BACnet MSTP is a data link layer, and it is also using a MAC address for its addressing, albeit not using Ethernet, it's using MSTP. So what happens is that Ethernet, when this switch starts off, it sends out a broadcast. And a broadcast is a message that goes out all the ports. And then the machines that are on the ports respond to this broadcast with their MAC address. And then their MAC address gets linked to the IP address that's assigned to that port. And that's how the ARP table is built. And then after that point, you start using what are called Unicast messages, which are direct messages from the switch directly to the host. Actually, let me change that color here. So a lot of concepts so far, and definitely be thinking of any questions so that once we move into the question section, I can answer whatever questions you have. But what's going on here is that you've got a unicast message between the switch and the host. So that is what happens once this ARP table is filled out. Okay? Now we're going to move on to layer 3, which is the IP layer. Now an IP address is a logical address, whereas a MAC address is a physical address, although it can be changed. It's typically physically assigned to a specific network interface card, whereas a IP address, it's a logical address. And there's two kinds of IP addresses, IP version 4 and IP version 6. And I'm not going to go into why there's two versions of IP addresses, just there are. And an IP address consists of 32 bits, and these bits are in a combination of network bits and host bits. And you'll often see an IP address written something like this, 192.168.1.x-24. And what that means is that there are 24 network bits and there are 8 host bits. And so once you know that there are 8 host bits, here's how you calculate how many hosts. And remember, I discussed hosts are the devices that are connected to the local area network. So the host equation is really simple. It's 2 to the nth power minus 2. And that minus 2 is going to be really important because there's going to be 2 specific things on this network that we really need to pay attention to. So with the dash 24, it would be, and I'm going to clear this off, a dash 24, so 2 to the 8th power, because we have 8, 32 minus 24 is 8, minus 2, so that's 256 minus 2, that equals 254 hosts. Now, why did we take 2 hosts? Well, we did that because we have a default gateway and a broadcast address. Now, remember that on a local area network, you send out broadcasts. Well, you can't send broadcasts across multiple networks. They don't travel across multiple networks. So if you have a protocol like BACnet IP that is broadcast dependent, then you have a broadcast address which will go and send out a message to every IP device on the network, which they then will respond. So that broadcast address is the address they respond to. Now the default gateway is the address if a device wants to get out of the network, it goes to the default gateway address. And this address is going to allow you to go to another LAN. So let's look at what that would look like real quick. So what that would look like is I've got a LAN here, and I've got a LAN here, LAN 2, LAN 1. I've got a switch with one device, so we're just going to call this host 1, switch 1, switch 2, host 2, and they're connected via a trunk link. So links between networking devices are called trunks, and links between hosts or clients and a networking device are called access links. So what would happen if H2 wants to reach H1 and they're on different LANs, then what H2 is going to do is it's going to send a message to the default gateway, and that default gateway is then going to have a route, which we'll cover that stuff in future episodes, and that route will tell this device how to get to this device over here. Now, an IP address consists of three main parts. The address itself. Okay. I don't know why I did that. The default gateway and the broadcast address. So if you are going and setting a static address, which we'll talk about static and dynamic in just a second, but if you're going and doing a static address, you're going to enter an address that is within the range. So for example, with that 192.168.1.x, so our range is 1 to 255, and we have two of those allocated. Usually the default gateway is the first and the broadcast address is the last, so we would really have 2 to 254 that we could allocate as host addresses. Now, this is not a hard set rule that the default gateway is the first and the broadcast address is the last. They can actually be any address. It's just that's how folks normally do it. Now, the funny thing is you'll see folks that will make the default gateway a non-standard. They'll make it like 16 or 32 or whatever. And they're doing that because they think that, oh, well, someone will scan it. They won't realize that's the default gateway. But if they could scan your network, they could figure it out anyways. So there's really no point in making that confusing. And then, like I said, the default gateway and the broadcast address as well need to be included, which we can see that if we look at here, like IP address, subnet mask, and no default gateway on that one. Yeah, there we go. Default gateway, IP address, subnet mask. So you can see that. Alrighty. And your default gateway, what you're going to as well do, and no, I'm sorry, I told you something wrong here. I said broadcast address is something you need to include. That is not what I meant to say. I meant to say subnet mask, which I haven't talked through yet. So let me go through that real quick. I have a lesson plan, but for some reason I left broadcast mask, or yeah, our subnet mask off. So as I said, 192.168.1.x/24, right? Well, in order for the switch to know that these are host addresses and this is a client, or sorry, these are network addresses, and this is a host address right here. In order for them to know that, you have to use something called the subnet mask, which basically, if all of these right here, if all of these bits are set to network, then it's 255. 255, 255, and then this would be 0. Now, if I had 1 bit set to network and 7 bits set to host, like a -25, then what would happen is this would actually then go and become, so you would have, it would be, what would it be? Off the top of my head, it'd be 128, right? If I remember correctly. Oh my goodness. Be 128. And the reason why is you have 128, 64, 32, 16, 8, 4, 2, and then 1. And these are called bit registers, right? And what happens is each one of these little segments here has 8 bits, as I mentioned before, and these bits have values. So if I have 25 bits turned on, the bits turn on from left to right. So for this segment, this octet right here, I would have something like this, and I add up the values of my bits, which gives me 128. Alrighty. So I know that's a more advanced lesson right here, and I definitely will cover IP addresses in a future episode. So if this is kind of flyby and above where you're at right now, don't worry. It's something we will talk deeper in. This is just more focused on LANs. All right, so then what I wanted to share with you right here is I wanted to share with you this little picture that I've got right here. Let me see how I can make it full screen. All right, hold on here. I want to make this full screen. Oh my gosh. User error. Okay, there we go. Let's make that full screen. Bear with me, folks. Why is this not going to full screen? Why is this split into... Oh, there we go. Wow, that was pretty silly. So here we go. I'm going to move this into sketch mode. Actually, I'm not going to be able to move that into sketch mode, am I? All right. I could sketch with this, though. So here is a view of a building automation system network, okay? And this building automation system network has a lot of different things on it that I want to cover here. The first off is that you can see that the network itself... Why is this so big? There we go. The network itself is using a IP bus right here, and they're calling it Ethernet, but what's going on here is that there's actually a couple things happening, right? Because as we know, we've got layer 2, which is Ethernet, but we've got layer 3, which is IP. And we can see we don't see a switch in here. We don't see a router in here, but they would have a switch, and the switch would be the one connecting all these devices to the IP network. Now what's going on here is that we're seeing these servers being connected to the IP network. We see the BAS supervisory devices, and then we see the field controllers on the field trunk. But we can also see that some of our field controllers are on the IP trunk. They are on the Ethernet IP trunk. And this is why it's really important for you to understand the concepts we covered earlier in the video, layers 1 through layers 3, because if you had to go and troubleshoot this network, and some common tasks you'll have to do with something like this as a building automation professional are the following. What you would have to do is you would have to go and address. So you would have to work with IT to go and create an addressing scheme for these devices. You would also have to go and create a subnetting scheme for these devices with IT. And that would be really important because in order for these devices to be on the network, they need addresses and they need subnets. The second thing you may have to do is you may have to do some troubleshooting. So for example, if these devices right here, which I'm going to mark in red, these devices right here cannot reach the internet for some reason, or can reach the internet, then you may need to go and implement or suggest the implementation of access control lists, ACLs, which are another advanced topic. You can see this could go pretty deep. And what I want you to take from this is that having a familiarity of layer 1, layer 2, and layer 3, and having a familiarity of local area networks is going to be really important for you because architectures like this, where you see the yellow is IP and the blue is your traditional field trunk, are becoming much more common. So it's going to be very important for you to understand this. All right, let me exit out of this. Yes, I know I'll leave without my settings. Okay. And I'm going to cover one last thing before we open it up for questions. All right, the last thing I want to cover at the IP layer is the difference between static and dynamic addresses. So static addresses are where you assign an address to a device and that address stays there. It does not change, okay? And then what we've got here, oh, why is my screen acting goofy? Hold on here for a second. It's looking like it's messed up. And let me look at the stream. Hold on here. Oh, no, it's fine. Okay. Alrighty. So static IP address is dynamically assigned to a specific machine. Okay, so it is, is statically assigned. I got threw off by my screen looking weird. Static IP is statically assigned to a specific machine. So this machine would go and it would have a static IP address, and that IP address would not ever change. Dynamic addresses are leased. And this is the most common address you're going to run into, and this is a challenge you're going to face with IT folks, is that they often are going to want you to use dynamic addresses, and you're going to want to use static. And the reason you're going to want to use static is, let's say you have device 1, device 2, and device 3. And they're using 192.168.1.1.2 and .3 as their addresses. Well, when they're static, it's pretty easy if you have a device fail and you can just go change it out and you know what IP address it is. If you're seeing traffic coming across the network and it doesn't make sense, you know what device that's coming from. Whereas with dynamic, what happens is that you get leased an IP address for a certain amount of time. And then once that time expires, you can lose your lease. Oh my gosh, I can't write. There we go. Your lease can expire, or it can just continue. But the thing is that you don't know. And if you have a power bump on one of these field controllers, you can actually lose your leased device address. Now, most manufacturers that have IP controls have dealt with this. They have ways to look at the device name instead of the IP address, but still, nonetheless, it makes troubleshooting much more difficult. So you would have to go and work out with IT whether you have a static or dynamic address. And dynamic is going to be harder to troubleshoot, but it's going to be easier to get IT to approve. All right, so that is the main teaching session of this lesson. And if you have any questions, go into the chat box. I'd really encourage you to ask whatever questions you have, and I will definitely answer them in the time I've got allotted right here. If you're looking to know more about information technology, I mean, this was a flyby. This was a lot of different topics that we covered, kind of bounced all over the place. But if you want to learn more about information technology, then I encourage you to go here to buildingautomationmonthly.com/store. And I have my information technology for BAS Pros course that you can go and enroll in. It's an online course that'll teach you kind of what I covered today, but a lot more information. So whatever you need to know and whatever you want to know about IT to be successful in your career, it's going to be in that course. And I really encourage you to check that out. So with that being said, let me see what questions we have. I'm not seeing any questions from the folks on the stream. That makes my life real easy, because then we can wrap it up once I wait a couple minutes to see if anyone has any questions. But the important things I want you to take away from this video are that there are 3 different layers of network communication, right? The physical, the data link layer, and the IP layer. And that each one has their own unique aspects. And depending on what you're doing, what problems you're encountering, you're going to use different troubleshooting methods, you're going to use different design methods, you're going to speak to IT about different things. So it's really important for you to understand what aspect you're dealing with. And like I said, don't confuse data link things like Ethernet with physical things like Cat5 cable. And with that being said, like I said, if you want to know more about information technology, I really encourage you to go to buildingautomationmonthly.com/store. Check out the IT course. I have a starter package that covers the first 6 modules, really gets you into pretty much most of what you need to know to have a baseline knowledge in IT. That's going to give you the ability to communicate better with IT and understand what you need to do to work with IT. I will be live again next Wednesday, and we will be going and discussing another topic that I think you all are going to find pretty interesting. It's going to be called How Can I Develop My Building Automation Technicians? So if you manage building automation technicians, or you are going and having to go and try to do your development yourself, then that's going to be a interesting topic for you, and I'd really encourage you to check it out. I'll lay out how I laid out my personal development plan, and I'll give you a template that you can use moving into 2017. With that being, or 2018, oh my gosh. With that being said, thank you so much for being here. I really enjoyed having you here. I enjoy teaching this stuff. It's a lot of fun. And I look forward to seeing you all on the next live stream next Wednesday at 9 a.m. Central Standard Time. So definitely click on the little bell icon. That will set up a reminder to let you know when this live stream is happening. Until later, take care, continue to grow in your knowledge, continue to challenge yourself, and I look forward to seeing you in the next episode.